I go by Myobi. I made that up a long time ago because at the time there were only 3 Google results. So I have all the Google results. But not anymore. Some people have copied me. I used to work at Wunderlist. We got bought by Microsoft. Autocorrect hates Wunderlist and corrects it to Wanderlust. So if you see that in the presentation, that means that I was up late and I didn't catch it, and I'm sorry. But I probably meant Wunderlist. And if you try to type Wunderlist, I guarantee you're going to get Wanderlust, like every time. So I work at Microsoft. I work on a design team right now. I'm building some tools for them. I don't know, just little things that they need. I made a dashboard before I came here. I like being in London. It's my first time in London. That's why I put a little hat. That's good. I hope to leave a lot of time for questions. Also, I know that lunch is next, and I apologize for that. I know that the whole time you're like, when is he going to be done? So I can quit any time. Just raise your hand. OK, there's no bad questions, so think about the questions that you want to ask so that you can ask them. I do normally run my own presentation software, which is very stressful. But I'm actually in the middle of a big refactoring, and I guess I can't use it. I broke it. This was me, and I was like, I couldn't get it done. So yeah, so I'm using Keynote, which I like mine better, but you know, that's how it goes. Also, I love this little remote I have. I just want to tell you about it because I love it. It has like, it's beautiful, and it has like one big button. And it's the only remote I can find that has like one big button, you know. So if you ever give a talk, or even at work, like, and it has this really cool mouse thing you can do. Like it has a gyroscope, and you can like, yeah, it's crazy. Either way, you should get that. So this talk is about persisting state, because that is what has dominated my life for the last 5 years, maybe. Persisting state turns out to be very complicated because you have servers and devices and all sorts of stuff. So I like to name everything. I like to, like, this is a thing, and this is a thing, and this is a thing, and then we'll save it under that name. And I spend a lot of time doing that. So I think it's really important. I used to be a designer, actually. And so when we talk about state, what we're really talking about is like emails and to-dos and insurance claims and stuff. So I think it's actually really important. And that's the only reason I learned programming. And then now my career has spiraled out of control. And I don't really do much design anymore. So I do primarily work on what we call distributed systems, which apparently is like, does anyone not work on a distributed system anymore? I don't know, but we call it like it's a big thing. I mean, it's just, you know, one network cable and boom, you know, everything's screwed. So also, I like object-oriented systems because I don't actually understand a lot of programming constructs, but I like the idea of objects. It helps me out. So I like things to be offline first. So I probably don't like a lot of apps because most apps aren't, and it really is frustrating. But yeah, so Wunderlist was offline first. It worked no matter if you had internet or not. And that changes how you have to think about things and how you have to name things and stuff like that. I agree with this tweet. I don't know. How long does it take you to read this tweet? Have you read it? OK. One person nodded. That's good. I like using functional languages, but I am very liberal with the definition of functional because obviously, like, you can use JavaScript in a functional way, and it is like actually almost the most object-oriented language because it doesn't even have classes and it only has objects and functions. So either way, but I like functional style because I like unit testing, and so that just helps me out, right? Either way, I've given you a lot of buzzwords. That's what I'm here for. That's what I do. So just a little timeout. This is a nice Picasso. I just thought it'd be nice. Yeah, so this is actually really what got me started down. Even just getting into Erlang or any really complicated distributed systems is because databases are terrible. And so we at Wunderlist were always asking this question of ourselves, like, how can we get rid of our database? Like, how could we have every person have their own database? And that would be great. So I'm not going to answer this immediately because that's what the talk's about. But I'll probably show that slide again, I think. I don't really remember. I have a lot of slides, and I hope I go faster. Yeah. So this is what a system looks like for probably like every app that we use generally. Some people work on peer-to-peer software. I don't. I work on software that looks like this. I mean, a lot of peer-to-peer software has been changed to look like this over time, like Skype and other things. So peer-to-peer is tough. I like WebRTC. I think it's awesome. You know, I want to use it more. It's not in Safari really yet, so we gotta wait. But yeah, so I think most things look like that. And then I found this cool picture from La Web, which is the best named conference, I think, because it's La Web. Code Mesh #2. And yeah, I don't know. It's a nice picture. So, and that's an emoji of a bento. So I like to say everything is a thing, and I like to come up with names for things. And so when I started at Wunderlist, I just opened Wunderlist, and I just started making names for things. And then we built APIs, and then we built databases and everything from that. So I started from the customer and was like, what are these things? And that is literally how it works. We made APIs for all the collections, and then each collection can serialize database access using transactions, and yeah. But we made a rule that every database can only really be touched by one application. And so we made this rule. And then that really affected how we created our apps. We ended up going like this. And so every database just really ended up being one table, and then it had an application in front of it. And this was our object-oriented style of our architecture. It was the best we could do. We were transitioning from like a very traditional monolith that didn't work. Like monoliths can work, but this one didn't, and so you start from that point. And so we ended up with a very like I encapsulated behavior and state under these names. There was access controls, everything. There was external APIs, internal APIs, and I really liked it. I think it's a very good way to do it. I think it's an easy thing to transition to, because you could just have one and then go to two, and then we ended up with I think we launched with 80. Yeah, I had written a script to generate Rails apps. It was terrible. But each one was very small, and then we eventually replaced all the Rails with other languages and things like that. So, and all of that's a lie. Tasks is a big one, and so tasks is actually a lot of different things. We didn't start out this way because I'm very lazy, but all the metrics were showing us that these concerns needed to be scaled differently. And we launch each app separately, and we load balance each app separately. And so when the metrics showed, like, our writes are really slowing down our reads, let's just not do those at the same time. And then we can have 10 readers and 2 writers or whatever we need, right? And so it allowed us to, having this idea of having these small named things that we could talk about really helped us. Just even with our reporting and everything, we could go to our dashboard and look like, how are task writes doing? And we got that for free because it's easy to instrument like a Rails app, right? Or like any kind of app, like a Play app, right? It's difficult to be disciplined to like instrument the parts of an app. And so if each app only does a very small thing, you kind of can be really lazy, but you still get all the benefits of being disciplined. Probably not true what I just said, but it sounded really good. Okay, yeah, our APIs were were designed to be like you're downloading each database table. So from the iPhone app perspective, it would be like, what are my tasks, what are my lists? They're all disconnected. There's no foreign keys or anything like that. And then the UI is actually completely off of local storage. And so that's what gives you that offline first capability. And that's really important to me. And so we spent a lot of time on doing the background sync, right? Like how do we do the sync in the background and then keep everything else? And, yeah. Just so you know, and I liked this before I worked at Microsoft, but they make this thing called Service Fabric, which is like a server technology. And they have a thing called stateful collections, which allows you to deploy a service under a name. And it's almost like this stateful array. And you can modify it, and you're guaranteed that your modifications happen one at a time and are atomic. And it's actually really, really nice. You should look at it if you've never seen it. The way they do it is they just put a partition map in Zookeeper, and that way each operation only happens on one machine at a time. And once you're on one machine, then it's very easy to make sure one thing happens. So this is very similar kind of what we did, except we just let the database serialize transactions, and they elevated that to the application layer. But yeah. PouchDB is a good example of how to do background sync and then use local queries. PouchDB is basically like a mobile version of CouchDB. And it's completely compatible with their sync protocol. And so you can run CouchDB on the server, and you can run PouchDB on the phone, and they sync as if they're peers, and then you can just query the database. And this is what their website looks like, and you probably can't read anything on Yeah, so we've went a long way off topic. You're like, is any of this really object-oriented? What are we talking about? I think it is. I do think that you can take object-oriented concepts and use them to do a good system. But obviously, like, we could do a lot better. Especially the people at this conference. Like, I went to a lot of talks, and I was like, I don't know what's going on. I don't know what you're talking about. Yeah. What you really think when you think of object-oriented is like I want to talk to task number 4, or I want to talk to user number 42. And you're like, how do we do that, right? And you know exactly what I'm going to say. AKKA. So I only say that because it's another, I like to go off on tangents. We use AKKA for Wunderlist because AKKA is very good at WebSockets. They have AKKA HTTP now, and it has WebSocket support. So we actually did use this model for mapping what we called our devices, right? And so your device did have an actor running, and you did communicate over a socket to it. And then it provided you different functionality to the other services. So this actor would then talk to tasks or talk to lists. And you could tell it, like, I want my lists, and then it would go get them, and then it would hand them to you. And it was very good at parallelizing all that stuff for you. So like, you could say, I want to do these 100 different requests to different services, and it would do them on the server, and then it would send you back the results, and that was really handy. So we did actually have this like tiny idea for devices. But we never were able to expand this out for Wunderlist purposes to any other concept. Because some things are just monolithic, and that's fine. Like, you should. I'm just trying to say, like, don't worry about it. Like, it's okay. You know, everybody knows this phrase, right? And it's dog. I don't know if you know the name of the person who drew it, but now you do. Because I don't like to put anything in there unless I know where it comes from. Either way, behavior is like, right? So we're talking about object-oriented. Behavior is easy. Right? We just write some functions. Boom, done, right? And we did this. We wrote our apps where like it's like get tasks was like get tasks. It did one thing, like return tasks, fine, right? That, I don't know. I feel like this is not too difficult. But then object state, like we're back to this again, finally, yeah. And again, I opened Wunderlist and I started looking at what is the state now that I have to persist, right? And where am I going to put it? And how am I going to get it back? And it turns out some things are easy, like the task title. You just save it. And then when it changes, you just save it again. We had a lot of debates about like whether you should merge it or not, like when there's 2 different changes. And I said, no, it's too short, right? It's not long enough for that. Also, that's difficult. So either way. But a really good way to do it is to use clocks, and not your clock. Human clocks are terrible, and you should never use them. You have to make a clock. The clocks that we use, I think, are these kind. The Lamport timestamps. We have a number, and we increment it, and I'm pretty sure that's what this is. If not, it's something else that is related. We didn't use vector clocks because they're complicated, because every person who makes a change has their own clock, and I didn't want to deal with that. So we have like a global clock for every object. So every task has a clock, every list has a clock, and that way we kind of know where in time it is and stuff like that. And that gives you a lot of flexibility. When you're making an update, you have to say, like, I'm making an update, but I'm starting from the 2nd version of this task. Well, if the task is on the 5th version on the server will be like, no, you're out of date. You need to download the old stuff and merge it in. We copied this completely from CouchDB. That's how CouchDB works. They have a little revision number, and you have to specify it when you make an update. So we just copied it completely. Ownership and membership are a little harder. You need like some sort of array or list or something like that. But you can do it the same way, and that's what we do. And then for each device, you're not actually downloading a whole database, right? You're just downloading a subset for that user or for that device or for whatever. And so you just make a decision, like what are we going to download? Where are you going to save it? Postgres. If you don't know what to do, you should use Postgres. If you have a lot of writes, use Cassandra. If you're on a device, use SQLite, and then you're done. Cool. Sorry about that. You probably know all this. Either way, I just wanted to repeat, and I'll go through a little more specifics of what we did. We use OS processes. We use run it to run them. We use console to make clusters. We launch a whole VM to run one process, and we build an image from every git commit, so we can do that. We really do. Anyone can launch process anywhere. We don't have any like master process list or anything like that. Every process listens on port 8000, speaks HTTP, serializes JSON, and uses statsd for metrics. Yeah, I call this our crappy actor architecture, or crapter. Just like, yeah. Either way, Erlang has the same thing, right? It has clusters and nodes and RPC, right? It has processes. It has state, which is called state, right? Where are you going to save it? Same places, I think. I think it's the same thing. So we're back to this question. What if every user had their own database, right? We just need to make some actors. I'm going to run very quickly through like AKKA again. I love it. It has a distributed actor registry. This is code sample you can't read. I don't like Scala. And I've never done Java, and I don't really plan to start today. So, but it's great. Like, we have some Scala services. Our WebSocket stuff, very reliable. It's actually the best services we have. I just feel like I'm maybe smart enough to like write Scala, but I'm not smart enough to like edit 6-month-old Scala, and that's what I'm working on. So, this is a video. I was just thinking about like Java, and this guy makes the world's smallest cup of coffee. Okay, yeah, that was really dumb, but I love it. I hope you like it too. Okay, Orleans is great. Microsoft made this. It's a C# thing. It's an actor. They call their actors grains, which is a really weird decision. And but it includes features like clustering and distribution, and it includes a distributed process registry as well. They use a distributed hash table. So they, instead of having like a central place, like AKKA, you have to have like a set of nodes that are responsible for the process registry, whereas this is like, it's like kind of everybody's kind of, whoa, what is it? Yeah, but you can auto-spawn a grain anywhere, whereas most other actor solutions will do a sharding, like a ring shard, and then when a node fails, they'll have to like redo the ring. Whereas this, like, you're just literally randomly placing them, and you just update the distributed hash table with like, it's on this node, and then you send that off to all the other nodes. You can write it in F#, which is hilarious. So that's what a grain looks like in Orleans. The distributed hash table is eventually consistent through, I think, I don't know, probably the buzzword gossip would be useful in this slide. Either way, they do say that they have consistent data guarantees because they actually just farm out their consistency to the backend storage. Their default storage is Azure Tables, and they just provide an E tag, like the last seen E tag when they do a write. And if the E tag doesn't match, then you must be out of date. There must be another actor that's a mirror of you somewhere that has updated as well. So instead of trying to prevent there from being a second actor, they just make sure that you can't overwrite another actor. They do try to, like, if they see another actor, then they'll choose a winner. But, you know, network partitions happen all the time. So it means, obviously, that you could read stale data if you were to go to the wrong actor, but it means that you can't overwrite data. So stale data is fine if you have clocks or something like that. Like, we use that for real-time sync. We didn't want to have to guarantee order of messages, so we use the clocks to know if we've seen something. That way, you could do the same thing with this. They do it with the E tags. So I want to use Erlang, though, because this is my statement that everybody's going to disagree with. Yeah. I think that's actually the trick, is without needing additional libraries. Like, if built in, it's actually extremely object-oriented because you have a clear way to encapsulate behavior and state with gen servers. I mean, it's just like right there in front of you. And so that's how you make objects. That's how you give them names. That's how you address them. I mean, it has messages, either way. Also, Elixir is my favorite Lisp. It's a really good Lisp. I like it. Macros are good. We'll argue about this at lunchtime. Either way, there's global, which you're like, global distributed process registry. No, your names are very limited. You have to use atoms. You don't want to do that. Also, like it's very eventually consistent. Like you can have two processes with the same name for quite a while. So then you just go to PG2, which is also eventually consistent. But it's very good. It's very good. If you don't mind being eventually consistent, if you don't mind the idea that you could have two processes with the same name at the same time, then this is the best one, I think. Phoenix uses it for its WEBSOCKETs. That's actually the code. I just copied and pasted code from Phoenix to make it look like I was cool. This is another file from Phoenix. Yeah, all the good process registries that I know of are eventually consistent, which means, again, your state reads can be stale because you asked an outdated process. And you're like, I heard about this Elixir has a registry. Yeah, but it's like for one node. So it's great if you're on one node, and actually like most distributed registries will use this on each node to keep track of the things on that node, but then the distribution is different. But you could do the same thing then as Orleans. And there is something, boom, I didn't do this. It already exists, called Orleans. It's space-time. I don't know what that is. But this looks cool. But I don't like this eventually consistent process registry. I really would like to know there's one process with one name, right? So of course, I've started some code. So this is a replacement for GenServer, a wrapper around GenServer that persists the state on every update, every time state changes. This is like a normal example GenServer that does what does it do? I forgot. Oh, it keeps a count of every time you ask it something. And this is using the persisted one. So you just give it an adapter module that has a get and a put, and it'll call get on init, and it'll call put anytime anything else happens. I don't know why this doesn't exist already, and I think it must. So someone who wrote this before me should let me know, because I'm sure it's better than mine. But I've been looking for a while, and I haven't seen a nice GenServer replacement that does a gen persisted server like that. I want a consistent process registry, but I don't want to learn Paxos. And so right now, I have a library to put the process registry in Zookeeper and just use Zookeeper directly. I'm sure smarter people than me could do it in Erlang or Elixir, but I don't think I can do it. This is how you normally start a GenServer in Elixir, and this is how you use the Zookeeper registry. You use the via syntax, give it a name. Again, see, I'm very big into naming, right? But then I can do this, and I know that there's one task 1, 2, 3, and I can address it from anywhere as task 1, 2, 3, and I know I'm either going to get 0 or 1 things back, which I really like. And then I have this other library called Highlander, which I want to wrap these other two and provide some convenience functions. And you might remember the show. Yeah, that's dumb. So the show Highlander, the whole point was there could be only one, and so I thought that was a joke for the idea that there could only be one process for that name. Either way, similar to my presentation software, they're not finished, and so there's a pattern there with me. But other things you can look at, there's this thing called LASP. I haven't used it yet, but they replace Erlang distribution and process registry with their own, and it looks really interesting. I don't know. Here's a video URL you won't remember, but you can find it in the slides later. And this is the title of the video. I didn't understand everything that was in the video, but it was really cool. And it was about how to keep track of all the crap in Internet of Things. There's this really cool thing called proto-actor, which is cross-platform actors. I don't understand that either, but that sounds really cool. I mean, it says it's in Kotlin, so I'd be I don't know if you're running this on the phone. I don't know. I want to do it either way. That's how I feel about that. So you might be saying, I don't do Erlang, and that's OK. I forgive you. We didn't use Erlang at Wireless either. Like I said, we just structure things with concepts. We just try to figure out how they collaborate, and you can do that too with anything. I don't really like dogma or anything like that, so this is just hopefully something that would be interesting that you could try to implement at work. Yeah. The best example, I think, of the best use case of this is a game, because I didn't make it, someone else did, called Halo. And this is how Halo works, actually. Halo uses Orleans. That's where Orleans came from. There's a really good talk. This will be in the slides later, so you don't have to write it down or anything. But they go over what it was like to build Halo on top of Orleans. And these are kind of the concepts that they named. So there's a game. So every game is an actor. There's a player, every player is an actor, and then every device, right? The Xbox is an actor. And they literally collaborate with message passing. They keep each other up to date. The game orchestrates the players. There's like a matchmaker actor, which puts people into games, like, and they really built out like all the different objects to facilitate like playing multiplayer games. And they found it was like super scalable, because right, like as your boxes fill up, you just add more boxes and you just fill them up with more things, right? And it was also really performant because the message passing had very low overhead. It was very quick, and I don't know. It also just seemed easy to talk about. So there's also an example game I found called Conrain. I actually didn't play the game. I looked through the code, though, and it's really interesting. This uses Orleans, and it's supposed to be like a smaller example, like unlike Halo, which you can't look at because they make money from it. I think the best game that I want to make is tic-tac-toe, because you can have like the same kind of concepts, right? And this is kind of what I would do. But then, luckily, like there's another thing we need to name that we haven't named yet, and that's the connection, because actually the connection has state, right? And then I want to persist the game state S3 and only have one, right? You're probably thinking, he wrote this, didn't he? We're all going to play this game. And I got really distracted with the tic-tac-toe. I didn't finish this game. This is the repo, like in the code, there is some code there. But like there are like papers about tic-tac-toe. And it is so interesting. Like you have to get into it, like about because it's a matrix, right? And people are like, is there one matrix operation we can do to determine if the game's over? And there's like so many arguments online about it, and there's like other papers I was reading about multi-dimensional tic-tac-toe and like combinatorial games, and like you gotta look into this, seriously. Also, I think rock, paper, scissors would be a good game because it's like a time-sensitive game. And I think that would be a really cool thing to do by modeling with like these actors, like in a Halo style, because how cool would it be to like have all the power of like Halo, but like for rock, paper, scissors? So this was basically the point of the whole thing. And this is the question that got me started and I haven't gotten there yet, I'm not 100% there, but I'm gonna keep probably building software and not finishing it and talking about this for a long time. So we're gonna do some questions. So I think I talked 26 minutes, so that's a long time for me. There are no bad questions, but don't like make a long statement that's not a question, you know? Because like really, like nobody likes that. Like,
just make it a long question instead.
And usually what happens when people say questions is like everyone claps right then and doesn't ask the question. And I'm okay with that, but I always feel really weird about it. And so I wanted to acknowledge the weirdness, but then let it happen. Oh, now I was gonna say.
Well, you didn't have to worry about running out of time.
I talk really fast, I'm sorry.
No, you didn't.
Oh, okay.
Yeah, we've got 15 minutes for questions, so go ahead. There's Joe.
It's also lunch, you know, I wanted to be respectful to the food.
You're going to disagree about this nonsense about Erlang being object-oriented, aren't you?
No, I recant. I wrote a paper saying why object-oriented programming is silly years ago, and then that was before, say, Faridi came up to me and said, Erlang is the only object-oriented language. And I said, why? And he said, well, because of this, that, and the other. I said, oh, yeah, you're right. I said that to Alan Kay, and he said, yeah, you're right. But that wasn't a question. That was a comment. Yeah, I was just thinking about this thing about why doesn't... You see, I don't understand databases. They seem to be horribly complicated things. And I didn't really... I was thinking this difference between every user having their own data. And so if I was doing it in Erlang, you know, I just use a nets table and use term to binary and stick it in there. So all my data's in one place and stick it in the file system in a file. That's very easy. And I thought the advantage of that is amazing because it's easy to replicate, it's fault tolerant, and it's scalable. You get that for free. What you don't get for free is aggregate operations. You can't say, find me all users you know, who like beer or something, because they're spread in these zillions of small databases. So if you've got a database, you can do aggregate computations very quickly. Find me all people who like beer. And if you've got individual databases where you've got all your own data, you can't do aggregate operations efficiently. Yeah. And it seems to me that perhaps there are ethical questions here. I think we should have all our own data, and I think it should be personal. I think it should be, you know, sort of in my pen or on my belt or something like that. And if people want to do computations on that, they should send the program to me, and I can decide if I wish to execute it. And I can also decide which of my data I allow to seep out for other people to see. So I think really we should own all our own data. Nobody else should be allowed to see it. And I think everybody should have their own database, and it would be physically located on them
Yeah.
and with access rights.
For some reason, when
extremely
you're talking,
limited. So
yeah.
I'd like to see that change.
Yeah.
And I don't think we should send all our data to the NSA for analysis.
It's funny because when you're talking, I feel like I have to raise my hand, I agree with you, but what I've noticed is that you can't actually have each person have their own database, but I feel like each shared thing can have its own database, and that's what I think we were trying to model. Like each list would be kind of its own database, and then it would have access controls on who could get into it, like which other people. And that way then you could have a copy of the shared things that you all do. And I think that's why I like that idea of the game, right? The game is the shared thing. And then the player has like their stats of how many times they've won and stuff like that, or how many games they've played. But the game is like that in the moment shared thing that links all the people together. And so I thought that was interesting. Yeah, but I agree. I do wish that we always joked that we would just have like a SQLite database on S3 for every person, but that's probably the worst thing we could do. But I think that'd be hilarious. If somebody wants to work on that, let me know. Are there any more questions or anything else?
Thanks. Well, you covered it just at the end. You're saying having SQLite on S3. Because you have SQLite on the app, then everyone has their own database per se. So why is it bad to have it all on S3? Just sync it that way.
If you do it where every like list would have its own database, then we could do it. Yeah. The problem is like with the way people collaborate, like people are in and out of collaboration scenarios, and so you don't want to have like the way actually. So like email is great, right? But it's terrible. The model of email is we copy an email, right? Like you don't actually send someone the email you wrote. Like the email you wrote gets saved to your mailbox, and then they get a copy. And then that way, if it was the same email, then when it changed, you would see the changes, right? And so with like Wunderlist or other collaboration software, you want to be working on the same thing. Like you want to be playing the same game at the same time. And if you had to copy that game to all the people all the time, I do feel like then you're really limited on the number of people that can collaborate at one time. So I think that's why we thought that it would never really happen. But maybe if you went out and you just had even more little databases, then maybe it would work. But then I think Amazon would get upset with API calls. And so someone told me there is a limit on S3 calls, and I told them I hope not. Yeah. Is there any more questions or anything? Is everyone hungry? Okay.
Well, if we're lucky, we can beat the queue. If that's all. Going once.